Good evening, everyone, and thank you so much for joining us. First of all, my name is Talia. I'm the Virtual Experiences Coordinator at the Denver Museum of Nature and Science, and I'm so excited to be your MC and moderator for this event this evening. I'd like to share a little bit of information about 60 Minutes in Space, as well as tonight's presenter. A lot of you may know that we've been doing 60 Minutes in Space every Wednesday night for the last, 20 years or so at the museum, but this is the first time that we've been able to offer it virtually. And we're so excited to be able to provide this live program tonight specifically for our members. So again, thank you for your support. Normally, as you might know, our space scientists, Dr. Steve Lee and Dr. Kachun Yu, share what's going on in the universe in this event, but tonight they were able to hand the mic over and hand the spotlight over to Dr. Graham Lau, who is going to be our featured speaker this evening. We're so happy that he was willing to shift his presentation to a virtual presentation tonight so that we were willing to keep this date with you. Dr. Lau is an astrobiologist and science communicator with Blue Marble Space Institute of Science and hosts the Ask an Astrobiologist show on NASA Astrobiology and SegaNet. He'll also make an appearance in our brand new Space Odyssey exhibition opening up in November, so don't miss it. If you like what you hear tonight, make sure to tune in for that in the fall. I'll go ahead and pass it on over to Dr. Lau, and again, thank you all for joining us.
Thank you so much for the introduction, Talia. Hopefully everyone can hear me. This is easily the largest audience of people I've ever spoken to, and here I am in my living room. This space wouldn't even fit all of us. And it's been really cool seeing all the different ages of all the explorers and scientists we have amongst us here. I saw ages as low as 3 and 4, 5, 6, 7, 8, the whole way up through the gambit of all ages. And so I'm really excited to share some of my knowledge about our universe with you, about our solar system, and about what we can learn more about life as we know it. So I'm going to do a little screen share here. All right, like Talia said, I am a member of the Blue Marble Space Institute of Science. There I'm a research scientist. I'm also the Director of Communications and Marketing for Blue Marble Space. We're a nonprofit focused on sustainability and developing a better future through space exploration and Earth system science, trying to better understand the nature of our world, the nature of our place in the cosmos. And I am an astrobiologist. That means that I'm someone who wants to know if there's life outside of the Earth, and I want to know what life is all about. Ever since I was a little kid, I wanted to know if there are aliens out there, what might they look like? Could they look like what we've seen in movies and in television before? Could they look like Yoda or one of those cool little aliens from the Claw from Toy Story? And the thing is, even though we have a lot of these ideas of how alien some things could be, there's some creatures right here on our planet that look pretty alien to us. The Portuguese man of war, for instance, is a siphonophore organism, this thing on the left with these long tentacles drooping down. It's not actually a single organism, but instead it's a colony of organisms living together and each of them taking on different jobs to work together. The same way that we humans live in communities like towns and cities, and we have to work together doing different jobs to make it all work. That's what an organism like that does. That sounds a little alien, but it lives right here with us. Likewise, we have this deep sea giant isopod, just like a roly-poly bug you'd find in your backyard, but it looks really alien. And when it comes down to it, there's a lot of really cool stuff living right here in this beautiful world with us. This image, it was taken by some of the Apollo astronauts as they were heading to the moon. And in this image, you don't see any borders. All you see is whites and blues from the clouds and the sea, some of the land in dark colors of browns and light colors of browns, where you see deserts and forests. Our world is dynamic and it's intriguing. And life has been here for a long time. And those of us who are astrobiologists not only want to know how life got to be here and how it's changed through time on our planet, but we also really want to know if there could be life elsewhere. We want to go out into our solar system and even beyond to look for signs of life and find out whether or not we're truly alone. And so maybe some of you right now at home could talk to each other and tell each other where you think in our solar system we might want to go as scientists, as astrobiologists, to find life. Maybe one of your answers could be Titan. Titan is a moon of Saturn. It has the thickest atmosphere of any world in our solar system, even thicker than ours. If you think about where the International Space Station is at orbiting the Earth, if the International Space Station was orbiting Titan, it would still be deep inside of that blue haze of an atmosphere you see here. Titan is really cold, and the surface is full of hydrocarbons, like the oils and stuff that we use to make gasoline, are all over the surface of this moon. So we'd love to study there and see if it could teach us more about life. There's also Enceladus, another moon of Saturn. This moon has an ocean underneath of an icy crust. And in its south polar region, there's these giant plumes of water that erupt. And we were lucky enough with the Cassini spacecraft to have the chance to fly through those plumes of water and learn more about them. But we didn't have the ability to really look for life with that spacecraft. And so hopefully in the near future, we'll send another spacecraft back to Enceladus and fly it into those plumes to look for life. But honestly, as an astrobiologist myself and someone who spent a long time thinking about what life could be like in other places and what life might have been like in the early solar system, for instance, if it was elsewhere, my favorite candidate for life outside of Earth is actually Venus. And for some of you, that might sound weird. Maybe you're way ahead of me already on where Venus is right now. But Venus is fairly close in composition and size to the Earth. And a long time ago in the early solar system, it very likely had oceans and might even had an atmosphere very similar to ours. Venus might have been a more Earth-like world than Earth is right now in the early solar system. But a long time ago, something happened to Venus. A long time ago, Venus went through a runaway greenhouse effect, where carbon dioxide and sulfur gases started building up in the atmosphere, warming the surface, which only caused more carbon dioxide and sulfur gases to go in the atmosphere and only warmed the surface more, and it got hotter and hotter. And this picture you see here is what Venus looks like with our naked eye. It's obscured by clouds. They cover the entire surface. We can't see down to the surface of Venus with our own eyes, but we can use spacecraft and other technology to help us look at the surface. So this is using radar from the Magellan spacecraft, looking down at the surface of Venus. In these various areas where it's light and dark, that's actually caused by differences in how rigid or how soft the rock are. So where the rock is really soft, it gets darker, and where the rock is really rigid and sharp, that's where it's really bright colored. But that surface of Venus also looks like it might have entirely melted and turned into a big ball of magma, maybe 500 million years ago or so. And so there's just so much missing about the early history of Venus. But we still have a lot more we can learn, even though we haven't sent a lot of spacecraft there in the past. And just recently, we announced some new spacecraft that are very likely going to be funded and sent to Venus to learn more. In the last month, we heard that Veritas now has the go-ahead to continue forward as a mission and might get funded. Veritas would fly around Venus in orbits around the planet, and it would do high-resolution mapping, teaching us a lot more about Venus's clouds and what they're made of, about the chemistry in those clouds. It would also study the surface and show us what the surface of Venus looks like, and will tell us more about the chemistry of Venus through time, helping us to understand how Earth-like is Venus now, and maybe how Earth-like was Venus a long time ago as well. Another mission is called Da Vinci Plus. Now, this one I really like because NASA hasn't sent anything to attempt to land on Venus since 1978. And really, honestly, we haven't landed much at all on Venus. On the surface of Venus, it's about 900 degrees Fahrenheit on average, very close to it. And that's really hot. You could bake one of those freezer pizzas in about 8 seconds at 900 Fahrenheit, but you'd be dead before you could eat it. But it's very hot, and the pressure is really high, about 92 times the surface pressure that we have here on the Earth. So it's hot, it's high pressure, it's a very bad environment for the instruments that we use to study planetary surfaces and to study space. But Da Vinci is going to be built to survive transit down through the Venusian atmosphere and study more of the chemistry and even study more of the surface for us to better understand its geology and whether or not there could be any life there a long time ago. And maybe even right now, there are some scientists who wonder if there could be life right now in the clouds of Venus. So around 51 kilometers above the surface of Venus, there's an area where it gets just right for life as we know it. The temperature, the pressure is just about the same that we have here on the surface of the Earth. And that's pretty cool for us to consider what's really going on Venus. But there are some other places in our solar system we really like to explore. One of them, for instance, is Mars, the red planet. This world, when you look at it in the nighttime sky with your naked eye, it looks very red. Ancient people saw it and associated it with fire and gods of war, gods of fire, these ideas of things that represented red to them. And it's because of all the dust in the Martian atmosphere and how it scatters light. For our eyes, it looks red. But if you look at the surface, it also looks kind of reddish, and it's in this picture brownish, but that comes from the rusting of the iron minerals that are on the surface of Mars. Now, we've been very intrigued by Mars for quite some time now. If you look back in even the history of science fiction, for instance, so in 1895, an astronomer named Percival Lowell looked at Mars and thought he saw signs of alien technology building canals to take water from the poles of Mars down to its equatorial regions. And because of that, the science fiction author H.G. Wells wrote a book called The War of the Worlds, which in many ways started all of alien science fiction as we know it. But now we've sent lots and lots of missions to Mars, lots of robots to go study Mars and learn more about its history, to orbit around it, to land, and even to drive around on its surface. And we haven't found life so far, but we're still trying to figure out if Mars ever had or might currently have life. One current mission that's there right now driving around is the Curiosity rover. Curiosity landed on August 6, 2012. I remember that landing so well. We were up in Yellowstone National Park with some friends for their wedding, and many of us were space nerds who loved geeking out over space stuff, and we actually put a hold on all of our wedding celebrations, even the bride and groom, so that we could all go find some Wi-Fi to pop out our phones and see if this rover successfully landed on the surface of Mars. And it did. And it's been 2,788 of our days, almost 8 years now, that this has been driving on the surface of Mars, teaching us more about Martian history, the Martian geology, trying to find out if Mars ever could have had life. When it landed in Mars, it landed inside of this yellow circle here called a landing ellipse. Actually kind of over in this area right here at the very top of the ellipse. Hopefully you guys can see my pointer there. In the middle of this big crater that's 96 miles across is a mountain called Mount Sharp, or Aeolus Mons. It's about 3.5 miles tall. It's a very big mountain in the middle of this crater. And inside of the crater, we saw signs of what looked like evidence of past water acting on the rocks inside of this area of Mars. And that's why we chose that to send this rover to. And it started driving up the edge of the mountain here, learning more and more about the geology as it went. So I'm actually going to leave this here. I think I have to do a full screen share here. Hold on for 1 minute.
While you get that toggled, we do have a lot of questions coming in.
Oh, I'd be happy to take some now as I do this.
Yeah, we've got a lot of questions coming in about Venus specifically. Like, is there water on Venus? And why do you think exactly? What are maybe the top couple reasons why you think Venus could be a good spot to look for life elsewhere in our solar system?
Well, that's a great question. There is water on Venus to some degree, but most of it's bound up in minerals, and it's in the atmosphere mixing around with other stuff. So, like, for instance, there's something called sulfuric acid. It's a mixture of sulfur and oxygen, and it has some water that kind of mixes in with it and makes it very acidic. The atmosphere of Venus is full of this sulfuric acid that rains down towards the surface and actually evaporates before it hits the surface and then goes back up. And so currently Venus at the surface doesn't have water. At 900 degrees Fahrenheit and so much pressure like that, it really couldn't have water in a liquid, an ice, or even gaseous form as we have it here on our planet.
Great. I've seen a lot of questions come in about things like, would a parachute burn up on Venus if a mission was trying to land on its surface? And it certainly sounds like it would be a very challenging place to land.
It is extremely challenging. So Da Vinci Plus, that spacecraft I was mentioning, it has a parachute, and it's going to use that parachute to go down, but we have to use special materials that are built to withstand that environment. So, for instance, 2 of the most successful missions to Venus ever were back in the 70s called the Venera landers. There was Venera 13 and Venera 14. The longest lasting one was Venera 13. It survived for 127 minutes on the surface of Venus. That's just over 2 hours before the pressure and the temperature destroyed the spacecraft.
Very good. All right. I've seen lots of questions sort of on that theme, so it sounds like a lot of people were curious. Thanks for answering those, and we'll let you get back to screen sharing.
Absolutely. So I'm going to share this screen right now instead. I hope you guys can see my YouTube video here. So this was released. It's a 1.8 billion pixel photo from Mars. It was taken from Curiosity just this past year, right around Thanksgiving time, actually. So while a bunch of us were enjoying Thanksgiving and going into Christmas time and our various holiday celebrations that many of us observe, this very, very large image of a panorama around the mountain on Gale Crater was taken by Curiosity. And here it's looking out across the crater towards the rim. Down here you can see an area where the rover tracks show where the rover just came from up this hill. And then out in this direction, you actually see the mountain, Mount Sharp, about 3.5 miles up, way up here above the rover where it's sitting right now. And then here you can also see something called the green hue pediment. This is a rock pediment, so the rocks up top are like really hard, about 3 feet thick, this really hard slab of rock laying on top of some softer rock. And we were hoping to get the rover up on top of that. So I will jump back here now if I can do, stop share with that. Yeah, so that's a really cool panorama to see the Curiosity rover up on top of this, basically this hill going up the side of a mountain, to see a 1.8 billion pixel panorama of it looking around to see all the cool geology of Mars. And for parents watching, if you're interested, there is a way to go on and explore with Curiosity. If you just type in Explore Curiosity rover in your search, you'll find a website where you can do a little VR moving around with the rover and have it drive a little bit on the surface of Mars, which is really, really cool to see. So I mentioned so from that panorama, I mentioned this green hue pediment you can see right here. This image was just taken in the last month on February 26th. The rover took a 360-degree panorama looking around itself on the side of the hill going up this pediment. So here you can see like there's a little drill hole where the rover was drilling. And the rover itself in this picture, you can tell it's gotten covered in a lot of dust and dirt over the years. It's going on 8 years now. It's been on the surface of Mars. And so it's getting very dusty. But now you can see in the background of this picture, a place where it actually went up and it climbed up on top of the pediment just in the past. Yeah.
Okay, Dr. Lau, before you continue, it looks like you may have stopped screen sharing for a second. Can we try backing out of your screen and jumping back in? Thanks for everybody for letting us know. We have a lot of people on this connection. We currently have over 1,400 people connected, so it's possible always that a connection can be disrupted. So thank you everybody for letting us know. Looks like backing out and then going back in has fixed the issue. Thanks everybody.
Awesome, great to hear. Thanks folks. So now the rover has just driven up on top of this pediment. And a really cool thing there for any of the engineers or people who are interested in how to build robots in the audience, it hit its maximum slope during that climb. It took them 3 drives to get up to the side of the hill and climb up over it. And at one point it hit 31 degrees. And so it got a pretty strong slope going up the side of that pediment. The rover was designed to take up to 45 degrees of an angle of slope without falling. But of course, the engineers don't want to push it to that limit. And so getting up to 31 is pretty high. It's actually not the record. The Opportunity rover had the record at 32 degrees. But it's very cool where Curiosity is right now as it's climbing the side of this mountain. In this image, you can actually see the rover track here in white. So down at the very bottom, the rover track shows the last few years where it's been driving. It drove into that green area at the bottom there called the clay-bearing unit, and then up onto this weird kind of teal-colored green hue pediment. It actually is going to spend a good bit more time yet driving through the clay-bearing unit in green. So clay-bearing minerals are minerals on Earth that form in the presence of water. And on Mars, they show us areas where the rocks likely formed with lots of water around, maybe even in lake environments or pond environments. And so right now, the rover is going to drive through this area that shows a lot of history of water. And then eventually it's going to make its way up into the sulfate-bearing unit. Those sulfate minerals are minerals that are often much drier. They form in environments with far less water. And so this represents to us a change in the geologic history of Mars going up the side of this mountain. And as Curiosity continues to climb, it's going to show us more and more of the geology, the chemistry, and more of the potential history for biology if it ever existed there in this area. At the very top, you see the Geddes Vallis Channel. That's a channel that appears to have been cut by a river flowing out of the side of the mountain and may have deposited what looks like boulders and some ridges in this Geddes Vallis Ridge. And so the rover in the next few years will get up there and start exploring that area as well, which is very cool. Curiosity has done a lot so far in its mission, trying to understand if there could have been environments for life in the past on Mars, trying to teach us more about the history of this region of Mars. And Curiosity comes from a long line of Mars missions. We've sent lots of robots to Mars. For those watching, you might know that Mars is the only world solely inhabited by robots. There are lots and lots of robots living there that we sent over time. Now, a lot of them no longer function, but some of them do. We have Curiosity on the surface. InSight right now is active on the surface. We have several orbiters right now flying around Mars and doing a bunch of really cool science, teaching us more about the surface of Mars, the history of Mars, the atmosphere of Mars. This image here on the bottom left is a picture of an upcoming mission proposed by JAXA. That's the Japanese Aerospace Exploration Agency. They're going to send a Mars exploration mission to go to Phobos, one of the 2 moons of Mars. And this mission is going to land and take some samples off of this moon and send them back to Earth. And recently I was talking to a scientist from Japan at the Earth Life Science Institute. He was telling me that there's a chance that if there was ancient life on Mars long ago, it might have been launched off the surface of Mars, traveled and crashed into Phobos, and might be there for us to go pick up as well. So this might be one of the very first sample return missions to bring a sample back that could have ancient life from Mars on it even, which is really cool. But yeah, so there's been lots of really cool missions sent to Mars through time. And we actually now have another one that's currently on track to launch sometime in July to August of this year, that for the longest time we were calling Mars 2020. But hopefully all of you have now heard that in the past month, the rover now got a new name. It's now called Perseverance. And that name was selected from an American school student. Over 28,000 students across the United States in their schools and homeschools and classrooms submitted names to the Name the Rover competition. And the winning name was picked from this young student. He's a 13-year-old in 7th grade in Virginia named Alex Mather. Alex submitted the name Perseverance and had the winning essay. I was lucky enough to be one of the judges in this competition, and it was really cool to see all of the different names that students had recommended and read all of their essays. I wasn't able to read Alex's essay originally. Unfortunately, someone else got that honor, but Alex's essay was very good. I'm hoping our connection is going to be stable enough. I'd like to actually show the video here of him reading his essay. It's only about 1 minute long.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. We're always curious and seek opportunity. We have the spirit and insight to explore the moon, Mars, and beyond. But if rovers are to be the qualities of us as a race, we miss the most important thing: perseverance. We as humans evolved as creatures who could learn to adapt to any situation, no matter how harsh. We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere. We, not as a nation, but as humans, will not give up. The human race will always persevere into the future.
Yeah, so that was a really, really good essay from this young student that won the name for the Perseverance rover. And just as we're persevering right now together as an audience with some of our technical issues, one thing I loved in Alex's essay was that last line, that the human race will always persevere into the future. We are explorers. We've been explorers. We're explorers still, and we will be explorers. And we want to know more about our place in the cosmos, more about life. Are we alone? What's going on? Perseverance, the rover, is just one more step along the way for us to continue asking this question of ourselves. So just like its predecessors, it's going to have a full suite of instruments to allow it to learn more about the surface of Mars, instruments for looking at the rocks and the geology and the chemistry and looking at the atmosphere and understanding more about Mars. So I thought for just a minute I'd talk about a few of these instruments. RIMFAX here is going to come from Norway. It's actually named after a Norse mythology named Hrimfaxi. Hrimfaxi was a horse. It's the horse that carries the night over the sky. And its name also kind of translates to frost mane or mane of frost. And this instrument will actually look down into the Martian subsurface within 30 feet below the rover to look for signs of frozen water and maybe even liquid water if it's really salty. It'll also have something called the super cam. On Curiosity, we have the mast cam. It has a laser on it that shoots out of its eye and can shoot rocks from really far away and teach us more. This super cam will do the same thing, but it's going to have two lasers shooting out of its eyes and hitting rocks within 20 feet away from the rover, and then learning more about the chemistry and about organic molecules and things that are inside of those rocks. Another cool instrument for those of us who are interested in sending humans to Mars is MOXIE. This is the Mars Oxygen In Situ Resource Utilization Experiment. This is going to test how we can use the carbon dioxide in the Martian atmosphere to make oxygen, not just for a propellant for our rockets to launch off the surface of Mars one day, but also to give our astronauts on the surface of Mars something to breathe. Now, this rover is going to go land inside of another crater called Jezero Crater that, much like Gale Crater, also shows signs of ancient action of water on the rock on Mars and might even have signs of life for us to find. And part of the mission of Perseverance, it's going to be the very first mission since the Viking landers, specifically designed to look for signs of life itself. So on board the rover, something else really cool, it's going to have a sample cache system. So as the rover is driving along, it can take samples of the rock that are really important for us scientists to study, and it can drop them along the way or in a big sample cache. Then later on, another rocket's going to launch. It's going to take a spacecraft to Mars that's sole job is to go pick up those samples and then launch them back up into the orbit of Mars so that yet another spacecraft can come and collect those samples and then bring them back here to Earth for us to safely study and to learn more about the history of Mars from it. Also, since I really love robots and gadgets and things like that, it's really cool. We're doing a tech demonstration with a Mars copter in the back of the rover. It's going to launch off the rover and go explore around Mars. And so there's a lot of really cool things coming in the near future with Perseverance. Again, it's going to allow us to persevere in our explorations. And there's yet other places for us to explore, to learn more about. We humans want to go out, like in the Martian, and you kind of wonder, what's it going to be like for humans when they first go to Mars? We want to get humans out into the solar system, get robots out into the solar system to learn more. Another place us astrobiologists really love is called Europa, for instance. This is a moon of Jupiter. It's just slightly smaller than our moon, but it's really a pretty big moon. And it has a very thick, icy surface. But that icy surface, we think, might only be maybe 10 kilometers thick or roughly 6 miles. And then down below that is an ocean that might be something like 60 or 75 miles deep. That's way deeper than all of the oceans that we have here on Earth. And so a lot of us want to know, could there be life down inside of that ocean? Might there be things like hydrothermal vents like we have here on Earth in our oceans? And if they're down inside of Europa, might they be places where organisms are thriving and creating a biosphere inside of that European ocean for us to study? This moon also means a lot for me as a scientist. I did my graduate research to earn my PhD studying a place that can teach us about this. 5 years ago, I was lucky enough to go to a place in the Arctic called Borup Fjord Pass. This is in the high Arctic, about 500 miles south of the North Pole. In this picture, and down in the very bottom center, there's some little orange dots. Those are our tents where we were staying beside this big glacier. In this region, we see where fluids down beneath the glacier that are really rich in chemicals of life and chemicals from the rock around it are coming up to the surface through the glacier. And when they come out, they make these really big yellow deposits of minerals, and those minerals are rich in sulfur. And so we've been studying the chemistry and the mineralogy and the biology of this field site to learn more. There's another place like that as well called Blood Falls down in Antarctica, where another glacier has fluids coming up rich in sulfur, but also iron. And that iron is meeting with oxygen and forming rust, iron oxide, that has this very blood red color. And so on two opposite sides of our planet Earth, we have these two sites that show us where fluids can move through the glaciers, through ice, and come to the surface. And those are really good for us to understand if there could be fluids moving through Europa for us to study at the near surface. For instance, sometime around the year 2024, we're hoping to launch the Europa Clipper. This mission should take somewhere like 3 or 6 years, somewhere in that range, depending on the rocket we use to launch it, to get out to Jupiter. It's going to orbit around Jupiter and Europa together and get a lot of flybys of Europa. It's going to study the surface of Europa, give us high resolution mapping. It's going to show us all the icy features all over Europa, teach us more about what's under the ice. We'll be measuring the thickness of that ice finally, and we'll learn more about whether or not there could be signs of life coming up from that ocean to the surface of Europa. It's a very exciting mission for those of us who are astrobiologists. But there are also other places for us to explore. So not all the time do we think about looking for life just in our system. It's entirely possible that there is no other life in our solar system. Maybe there is no life on Mars or in ancient Venus or on Europa or other places, but we're now discovering more and more worlds around other stars. These worlds called exoplanets. I just checked today, we're just over 4,000 confirmed exoplanets so far, with many more awaiting confirmation. And we're on the way to discovering more and more of these worlds, maybe some of which could have life. Currently, there's a mission in orbit called the Transiting Exoplanet Survey Satellite, or TESS. TESS so far has only confirmed 43 exoplanets, but it has well over 1,000 that it's waiting to confirm. And we believe that in the coming year or two, that we might have 10,000 or 20,000 more exoplanets discovered with this little satellite. It's looking all around the sky from our southern hemisphere and now in our northern hemisphere, looking around to see within 30 to 300 light years if there are other worlds, even Earth-sized planets around nearby stars. And in the very near future, we're going to launch the James Webb Space Telescope. Now, this has been coming for quite some time now. It started development in 1996, was originally supposed to launch in 2007, and then we had lots of changes to the mission and the structure. We went over budget a lot. It's currently on schedule to launch in March of 2021, March of next year. And a lot of us are really hoping it does. This has been called the successor to Hubble. So this really big mirror on this telescope, it's a 6.5 meter or close to 20 foot diameter mirror, will allow us to look as far as we've ever looked out into the observable universe, to look at the earliest galaxies, the earliest stars, for very large stars, to understand more about worlds inside of our own galaxy, to even look at nearby exoplanets and look at their atmospheres, to see if we might find signs of life inside of some of those atmospheres, the right chemistry, or maybe we'll even find something called technosignatures, signs of technology, of life in nearby worlds, which would be really cool. And it would teach us a lot more about who and what we are. As Alex Mather wrote in his essay when he named perseverance, we humans, we persevere, we move forward, we progress. There have been times in our past when things have harmed us, been difficult for us to deal with. We've worked through tragedy, we've worked together to get through our problems, to learn more about ourselves on this beautiful blue marble of ours, to learn more about life and our place in the universe. As an astrobiologist, I'm honestly very hopeful right now for our future. And I know that can be hard to say sometimes, especially sometimes like now for some people. But I am. I think we have a lot of potential right now to learn more about who and what we are, especially when we're working together to do that. And so I think I might wrap it up there. I do want to mention that I do host a show for NASA called Ask an Astrobiologist, where I speak with other astrobiologists from around the planet about their research, about the things they're looking at. If you just type in Ask the Astrobiologist, our next episode is next Monday at 11 o'clock here in Colorado time. And it's just been really fun for me over the years to have chats with all these other astrobiologists who are using their research to try to understand life in all these various ways. There's so much for us to learn when we work together. And so I think I probably have a lot of questions. So I think I'll stop it right there and open it up to all the possible questions you can ask.
Yes, you do. You have lots of questions. Thank you, everybody, for listening along. And thank you, Dr. Lau, for that incredible presentation. I have to say that is a really uplifting message that I think is pretty wonderful to hear right now. Perseverance is our way forward. So hopefully everybody was just as moved by that as I was. So we do have a lot of questions coming into the chat. In fact, I do see one. Perhaps you can share this right now. Some people are wondering if you could provide that website to interact with Mars. So maybe that panoramic tool that you were using.
Absolutely. Yeah, the panorama can actually just be found on YouTube itself. So you can just go to YouTube, and the Jet Propulsion Laboratory has that panorama. Give me one moment here, and I will open up the website so I can find that other one for you.
Okay. There is a true wealth of web-based tools out there. And I do see a few people popping in the chat to say, could you give us a link? And I think that's what we're working on at the moment.
Yeah, so what I'm going to drop over here in the chat right now is going to be a link to a virtual experience for parents and students where you can go and see Curiosity on the surface in a three-dimensional model and watch it drive around to some of the various places it's actually been on the surface of Mars. Also, I'm dropping in a link right now. That goes to a YouTube video that you can see that 1.8 billion pixel image that allows you to move around the image and look at all these different things, including at the rover itself. You can see the radiation assessment detector called RAD on the surface of the rover that studies radiation coming down to the surface. It's also the only instrument we had on the whole way to Mars. And so that instrument was studying the radiation on the way to Mars as well and teaching us what astronauts might go through. Also, another cool fact, on top of the rover, you'll see a little sundial sticking up. All three of our last rovers have had sundials on them that allow us, one, to calibrate our cameras, but it's also a really cool way for us to see the angle of the sun in the sky around the rover as well.
Very good. Thank you for that question, and thank you for dropping those links. I did copy them, and I do have them queued up in my chat ready to go, so I will hit enter on that right before we end today, just in case the chat has already put those out of view for you. So we will share those one more time before we disconnect. I see a lot of questions about Mars, including how big is Mars?
Oh, how big is Mars? I don't have a number offhand. It's much smaller than the Earth. The gravity on Mars is about 1/3 of the gravity we have here. So if you've ever seen the videos of the astronauts who are bouncing around on the moon, we sent 12 astronauts to the moon. And you ever see those videos of them bouncing around and falling over? It's because they weren't used to that very low gravity. The gravity on Mars is a bit higher, but still much lower than Earth. And so our first astronauts to Mars are going to have the fun of seeing how far they can jump. And wouldn't it be cool if they can actually break some Olympic records by jumping farther than our Olympic athletes, even while wearing these giant spacesuits?
That would be pretty cool. We'll just have to see. I do actually see a lot of questions related to traveling to Mars as well. So how long do you think it will be before we actually land on Mars? And what sort of technology are we going to have to develop in order to make that possible?
That's a great question. We've been saying for so many years, we're like, in 20 years we'll go to Mars, in 20 years we'll go to Mars, and I've been hearing that since the early 1990s, that in 20 years we'll go to Mars. I went to space camp when I was 13 years old down in Alabama, and I heard then that when I was 30, we'd be going to Mars, and I'm not quite that young anymore. And so it's kind of saddening, but at the same time, I'm very, very hopeful it's going to happen soon. There are more analog bases all over the world now. China's building one. Israel has built a Mars analog base. We have one here in the US in Utah. There's one out in Hawaii called High Seas. There are many of us who are interested in getting humans to Mars now. There are various groups involved in trying to get more interest in getting humans to Mars. We want to see what's going to happen when we send humans there. So right now, based on our current propulsion technology, it's something like a roughly 6-month trip. It could be shorter, maybe 3 months if we went a little faster. with some of our upcoming rockets. But right now we're looking at roughly a 6-month trip to get to Mars, maybe 1.5 years in the surface, maybe 6 months back. So maybe like a 2.5-year-ish kind of mission. Now, with that said, with that radiation assessment detector on Curiosity, we learned that there's actually more radiation on the way to Mars and on the surface of Mars than we did think before we sent that instrument. And that tells us that we're going to have to work a little bit to take care of our astronauts to keep the radiation from harming them. But there are ways for us to do that, to shield the spacecraft, to shield them on Mars. Also, we know that when we send astronauts to the International Space Station, when astronauts went up on Mir or the old space shuttles, they slowly saw their bones weakening a little bit and their muscles start to atrophy or slowly go away. They lose some of their bone and muscle. And so because of that, we know that we have to figure out how to help astronauts exercise better and maintain as much bone density and muscle mass as they can. But we also want to find ways to combat that slow loss of their muscles and their bones through time. And there have been some really fun proposals for how we could do that on the way to Mars. And on the surface, at least we'll have some gravity to help a little bit. And then other things we'll need, obviously we need food, we need water, we need air. And we're learning now, like with MOXIE on the upcoming Perseverance rover, we're going to see if we can create the oxygen we need to breathe out of the Martian atmosphere itself. So we don't have to take it all along with us. But yeah, there's so much more for us to do.
Very good. I do actually see a couple of questions about this process that you mentioned of transforming carbon dioxide into oxygen. So how would the carbon dioxide, I think some people are asking, how does the carbon dioxide get to Mars? And maybe you can tell us a little bit about the Martian atmosphere. And is this a technology that we could employ on Earth?
Yes, absolutely. So it's actually a technology we are employing currently. It's an electrochemical process. So we use electrochemistry in fuel cells. And we've studied them a lot in the lab. We use electrochemistry to make different kinds of batteries and understand how they might work. The electrochemical process we're going to use on MOXIE on Mars is going to take carbon dioxide from the actual Martian atmosphere itself. And it's going to convert that carbon dioxide into oxygen and carbon monoxide. So basically taking the carbon dioxide and breaking it apart and making new molecules out of it. Oxygen for fuel for our rockets and for breathing, and then carbon monoxide that we can just then pass on back into the atmosphere. Now, that carbon dioxide, so Mars also has an atmosphere, just like Earth has an atmosphere, Venus has an atmosphere, Titan has an atmosphere, but Mars has a very, very thin atmosphere. The pressure on Mars is really low compared to here on Earth. But even then, with that very low pressure atmosphere, it's still mostly carbon dioxide. And so for MOXIE to work, all it needs to do is just breathe in that carbon dioxide from the Martian atmosphere, and then it has its material to work with. Now, the temperatures inside of MOXIE are going to get very, very high. I think I'd read 800 degrees was the max temperature it's going to go up to make this reaction function. And so that's going to mean that they have to find a way to control not just taking the carbon dioxide in and measuring the O2 and the CO coming out, but also making sure that the heat from this instrument is then being controlled as well and not harming the rover.
Really interesting stuff. It seems like there's a lot to figure out. And it sounds like from everything that you've shared so far, we're going to need scientists with a lot of different backgrounds to really make travel to other planets possible. We're going to need engineers, but we're also going to need botanists, to help us figure out how to grow our food. I think that's one of the most interesting things about this new journey in humanity.
Absolutely. And I would even argue that we're going to need artists. We're going to need musicians. We're going to need people who have a different kind of way of seeing themselves in space and making sure everyone doesn't just, lose it on their way there, because we need a better understanding of ourselves and placing ourselves as humans on the journey. And so that's why I've always advocated for a very good liberal arts education, which means mixing your science and your engineering with history and theater and music and art and all kinds of different ways of understanding who and what we are. Science is a tool. It's a tool for us to understand more about ourselves, but it's not the only tool that we have for understanding ourselves.
Very good. Sort of on that note, we do have a couple of more philosophical questions.
Oh, I love those.
I know. And a couple of questions a little bit more about wanting to get to know you, which is always very cool. We have a question wondering, what is your favorite thing to learn about with space, or maybe think about when we think about the history of humanity in space?
That's a great question. And there's two very different questions, by the way. So the first for me I grew up very much loving science fiction. I'm an avid video gamer. I love playing science fiction video games, especially ones with aliens in them. I've always loved Star Trek and Star Wars, comic books that involved aliens, anything with aliens, really, I loved growing up. And so for me right now, astrobiology right now is at this really crucial point in our history where it seems that if we're not alone, it seems like we're so close to figuring that out finally, because we now have the technology. We now have the ability to look out to see these exoplanets, worlds around other stars. When I was born, I was 13 years old when we saw our very first exoplanet. When I was born, we didn't know for sure if other worlds existed out there. And so now, for me, it's so exciting to wonder, if there is alien life out there, what might it be like? Will it be anything like us and all this beautiful life we have here? And then for human exploration, our human journey has just started. We are like infants who've just barely reached our arm outside of our crib to test and see what else is out there. There's so much more for us to do yet in space exploration. Some of you might have heard of the overview effect. It was coined by this man named Frank White. It's an idea that there might be a psychological shift that astronauts feel when they go to space and look down and see themselves, not as Americans, not as people from North America or some other continent. They see themselves as humans on a very small spacecraft orbiting around this one rock in space that we're all on together. They see us as a species united, a biosphere united on our planet. And I think for us as humans, as we start leaving our cradle even more and more and stepping further and further away, we are going to start really having a much better idea of what and who we are.
It's a great message. I wish I could just embroider that on a throw pillow or something so that I could see it every single day. That's wonderful. When did you first want to start studying space? Or maybe how did you find yourself with a career in astrobiology?
Oh, that's a very good question. I'll start off actually first with science. When I was 5 years old in 1988, my parents took me to see a movie in the movie theater called Young Einstein. It was a comedy movie from Australia about a fake life of Albert Einstein. It's called satire. It wasn't real, but it had a really great 80s music soundtrack. And it has just inspired me a lot to think about physics, to think about science. That night when I went home, I made my very first guitar out of a shoebox. And now I must have gone through 12 or 20 guitars now. And that night I told my mother that I wanted to be a scientist. And I've stuck with it since. And the journey has been fun. It's been long. There's a lot of cool things you can do in science. There have been times where I've changed my mind a little bit. So I started off with degrees in biology and chemistry. I started at a small liberal arts college in Pennsylvania called York College of Pennsylvania. There I earned some degrees in biology and chemistry. During that time, I also worked at the Graduate School of Oceanography in Rhode Island, doing some marine molecular biology on diatoms. I worked at NASA's Ames Research Center doing some aerobiology. That's trying to understand the biology of our atmosphere and sample material of organisms high up in our atmosphere. And then when I graduated, I actually spent a little time still being a scientist, but also focusing on martial arts and my martial arts training, which I've been doing for well over 30 years now. And then I went to CU Boulder here in Colorado. I studied astrophysics for a few years, and then I earned my PhD in geology. So I've jumped around in a bunch of different studies of science in biology, chemistry, astrophysics, geology. And it's really cool, all the different ways we can understand our place on Earth, what our Earth is made of, what life is about, what we currently understand at least of what life is about, and to learn more about our place in the cosmos.
Yeah, you are living proof that no scientist has to choose one thing necessarily to have a really cool career.
It's true.
That's great. Here is a question from Elizabeth, who is wondering, if we find life elsewhere in the solar system, do you think it's likely to be similar to life on Earth, or is it more likely to be different?
Okay. So when it comes to life, we only have one example of life. We call it the n=1 problem. It means that the sample of life that we have of all kinds of life only equals 1. There's one biosphere. And so far, it seems likely that if there is other life out there, it will have some similarities to life as we know it. It will also want to use energy. It will also want to reproduce. It will also need some way to adapt to its environment to evolve through time. And so there are some things we think will be very similar. But there's also the potential for some really great dissimilarities, for some things to be very alien to us. So for instance, life as we know it, we have different kinds of biomolecules, things that make us up, like our sugars, our amino acids, our nucleic acids, our fats. And sometimes life as we know it makes a preferential decision about using one kind of a molecule. And so for instance, some molecules have what we call handedness or mirroredness. And so just like you have a left hand and a right hand, you can put them together and they look the same. But if you overlay them, your thumbs aren't in the same place. That's the mirroredness, the handedness. And that actually happens in chemistry too. And our amino acids and our sugars both have a very specific handedness. They chose the left hand over the right hand, for instance, or the right hand over the left hand. And life does that across the board on Earth. It might be that life out there in the cosmos, maybe in Europa's ocean or ancient life on Mars, might have used a different type of that molecule, the other hand. And that'd be really cool for us to see. Also, when it comes to how organisms work together, so very early in my talk, I mentioned that siphonophore, that Portuguese man-o'-war, and I highly recommend looking these things up. There's so many cool creatures on our planet to learn about, but they're one of my favorite. They are colonial organisms. So they are a large collection of different beings working together as one large organism. Maybe we'll discover that multicellular life that we know isn't very common. Maybe things like siphonophores are more common in the cosmos. And so maybe even the ways that we get around, so we ambulate, we walk, or we fly, or we swim, we've created appendages to do those things with. We've created different ways to interact with our environment to perceive it, like having eyeballs and taste buds and ears, different types of senses. Aliens might be very different. One of my favorite talks that I also give is about the craziest creatures on Earth, the weird things that happen here. So for instance, one of my favorite crazy creatures is a moth. This moth has the greatest hearing range of any organism on our planet. So we humans hear about somewhere in the range of like 20 to 20,000 hertz. That's a vibration per second. So 20 vibrations per second to 20,000 vibrations per second is what our ears pick up. These moths, they hear from about 50,000 vibrations per second to 300,000 vibrations per second. They can actually hear our airport beacons as they're going off in the radio range. And so not only are they hearing much different things than we're hearing, but their hearing range is entirely outside of ours. And so we don't even have the ability to imagine with our own minds what it's like to hear the way those moths hear. And so if there are things on our planet that are that alien to us already, imagine what alien life might be like.
That's pretty astounding. I am a biologist, and I still find my mind blown all the time by the things that exist on this planet. And there were lots of people who had a version of that same question. So perhaps all of us are spinning in our heads now of what some life in other parts of our solar system or beyond could look like.
Mm-hmm. Absolutely. If you like that question, I recommend going online, researching weird biology on Earth, and then just spend a minute just wondering, is that stuff somewhere else, or it could be even weirder?
Very good. Now we have just a couple of minutes left, and so I have two final questions for you, and I think these are two good ones to wrap it up with. Number one, do you think there is life on other planets, conclusively?
Ooh, so that conclusively is really tricky.
That's true. That's true.
I'm trying to trap a scientist.
We have gotten many questions this evening about, so
yeah,
are they real?
Yeah, so as a scientist, I have to say we don't know. So many of you museum members know that Space Odyssey is currently being renovated and will reopen as Space Odyssey Reimagined. But on the old Space Odyssey, on the wall, you might have seen that Arthur C. Clarke quote, that sometimes I imagine we're alone in the universe, and sometimes I imagine we're not. And either way, it's kind of startling, right? That yes, maybe we're not alone. Maybe there's things out there. Maybe we are. Either way, as scientists, we want to know. A lot of folks remember from the X-Files that Fox Mulder would say, I want to believe. Well, scientists, we like to believe, but we want to know. So for me personally, as a human being, I believe that there really likely is life out there. It feels like there has to be. And I want there to be. I want there to be more, just for us to have some neighbors to go hang out with, and go say hi, and maybe share recipes for how we do things.
Do they have instant pots on other planets?
Yeah, exactly.
No.
But as a scientist, we have to say we just don't know. Not yet.
Not yet. There it is. That's the important nugget right there, is we don't know yet. All right. And then as our last question, before we wrap up today and say a big thank you to our audience for joining us this evening, do you have any advice for any young or young at heart aspiring astrobiologists?
Well, absolutely. And as many of you can tell now, right now, we're engaging as a large audience of people together online. The digital age, the internet age, has changed things for us a lot as humans. There's now so much information available online. And if you'd like to learn more about what we're doing as astrobiologists, there are lots of ways to find out. NASA has an astrobiology website. It's astrobiology.nasa.gov. We have a lot of information on there. Last year, I wrote 50,000 words of curricula for school students to help school students learn about astrobiology through NASA Astrobiology. We have our show. There are other astrobiologists who want to connect in various ways, lots of ways to find information. But for those of you who want to become scientists or just know more about science, one is stay curious, ask questions, and never allow yourself to just accept the first answer. Always question yourself, because sometimes your first answer might be wrong. A lot of scientists have to learn along the way that just because you wanted it to be right doesn't mean it's going to be right. And it's really hard when you're studying science to find out that the one thing you wanted wasn't true. But then it's really exciting because then you get to go study more stuff and learn more about these really cool fields. Also, if you're interested in astrobiology, so again, astrobiology is this quest to understand life in the cosmos. There's a lot of ways into it. You could become a biologist, an oceanographer, a geologist, an astronomer. You can study history and still get involved in astrobiology. You can study philosophy and still be an astrobiologist. We have people who are involved in astrobiology who are graphic artists and videographers, people who are helping us to share the story of astrobiology. And in that, they also help us share the imagination, the human imagination that helps us to ask better and better questions. And so I will tell you right now that everything you choose to do in your life will allow you to be an astrobiologist.
That I could not have imagined a better way to wrap it up, and we are right at our time, so it is time for us to wrap up. Thank you, Dr. Lau, for sharing your incredible knowledge with us this evening, and a huge thank you to all of our members who joined us this evening. We are so happy to have you as part of our community. We are so grateful for your support, and we are so glad that we were able to bring this special experience to you wherever you are watching from today. So thank you for tuning in. Thank you for being patient as we figured out some glitches. This is a new format for us, but the reception's been great, so who knows? Maybe we'll see you again on here sometime. It's been great. Thanks, everybody.
Bye, everyone.
Stay healthy. We'll see you next time. Bye, everyone.